Hello, welcome to my channel. Have you ever wondered why deserts are so dry? Well, in this video we're going to learn about the 4 main reasons deserts exist. When we hear the word desert, we often picture scorching hot, barren wastelands with endless sand dunes and zero life. But deserts are much more diverse than that. They pop up on every continent and have varying characteristics. They can be hot, cold, found on coasts, at high altitude, and even at the poles. And if you look hard enough, a variety of life specially adapted to the harsh conditions can be found. Another common misconception is that deserts are mostly made up of endless sand dunes, when they only make up about 10%. The rest is mostly filled with barren rocky surfaces and bare mountainous terrain. So what defines desert? It's all about rainfall, or lack thereof. If a place gets less than 25 centimetres or 10 inches a year, it's officially a desert. Deserts cover about 1/5 of the Earth's land area and are home to around 1 billion people. But why do deserts exist? Let's dive into the 4 main reasons behind these fascinating landscapes. Let's kick things off with atmospheric circulation, the grand magician behind subtropical deserts. So picture this. At the equator, intense heating from the sun causes hot moist air to rise. As it rises, it cools and condenses, forming clouds that burst into heavy rain. This is why the tropical rainforest is so lush. This area is known as the Intertropical Convergence Zone, or ITCZ. This cooler, drier air mass then moves away from the equator and sinks between around 15 and 30 degrees north and south of the equator. The sinking dry air warms again, which limits the formation of clouds, resulting in very little rain. This is known as the Hadley cell. There is a second cell just above this known as the Ferrel cell, which also has air sinking at around 30 degrees north and south of the equator. And finally, there is a third atmospheric cell known as the polar cell, but we'll get onto this shortly. The Sahara Desert, the largest desert in the world, is a prime example of this phenomenon. The word Sahara literally translates from Arabic as desert, and this desert is mind-bogglingly large. It covers 9.2 million square kilometres and is almost the size of China, and covers about 8% of the Earth's land area. Moving on to the second reason deserts exist, the rain shadow effect. Imagine moisture-laden air hitting the windward side of a mountain range. As the air is forced to rise, it cools and releases its water as rain. But by the time the air descends on the leeward side of the mountains, the air has lost its moisture, leaving this side of the mountain range starved of rainfall. An excellent example of this is the incredible desert landscapes of Death Valley in the southwest United States. Here, eastward moving air masses laden with moisture are forced to rise over the Sierra Nevada mountain range, where the moisture is released as rainfall. As the air sinks down into Death Valley, the air is dry, giving rise to the arid conditions. And Death Valley lives up to its name, being one of the hottest places on Earth. The third type of desert on our list is coastal deserts, which typically sit on the west coast of continents, particularly in the southern hemisphere. One of the best examples of a coastal desert is the majestic Namib Desert in southern Africa. The Namib Desert is considered to be the oldest desert on Earth, and is also home to some of the planet's tallest dunes. The aridity of the Namib Desert can in part be attributed to the cold ocean current that flows from the south up southern Africa's Atlantic coast. Air masses moving towards shore are cooled by contact with the cold ocean, which creates a layer of fog. This fog can drift on land, but the atmospheric conditions needed for rainfall are absent. So while this atmospheric moisture can provide some water for specialist plants and animals, the lack of rainfall means conditions are still very dry. The extremely arid Atacama Desert in South America is another example of a coastal desert. This is in fact the driest desert on Earth, with some areas having never had any recorded rainfall. Fourth, we have interior deserts. These arid expanses are found deep within large land masses, far from the moisture source of the oceans. Quite simply, by the time air masses reach the interior of large land masses, they've lost much of their moisture through rainfall. Take the Gobi Desert for example. Spanning vast areas of China and Mongolia, it's nestled in the heart of Asia, far from the oceans and any source of rainfall. And finally we have polar deserts. These are, as you might expect, characterised by very low temperatures and arid conditions, and includes part of the Arctic in the northern hemisphere and Antarctica in the southern hemisphere. You might think that there is an abundance of water at the poles, but it's locked up in snow and ice and largely inaccessible to plants and animals. Much of Antarctica is a polar desert which, similar to subtropical deserts, is caused by sinking air, which inhibits the formation of clouds. But instead of the Hadley cell, it's the polar cell doing the work this time. Despite the extreme conditions, miraculously, life can be found in the polar deserts, from lichens and specialist plants to an array of microorganisms. So there you have it. Deserts aren't just barren wastelands. Next time you think of a desert, remember all the life, diversity and science behind these extraordinary landscapes. Until next time, keep exploring the wonders of our planet.